Hello, I'm Lily. Welcome to my thesis defense on improving research with big data visualization with a look at firearm deaths in the United States. So let's go ahead and jump right in. Technological advancements in the 21st century have given us an immense amount of data just sitting at our fingertips waiting to be used. Our technology has evolved, allowing us to create more data, store more data, access it easily, and be able to quickly visualize it. Comprehensive studies that visualize big data are incredibly important as they can pose new questions, help find solutions to seemingly unrelenting problems, and present complex information in a way the general public can understand. With all the changes that have happened in recent years, we should be looking at changing our research methods to adapt to life in the information and digital age. What I propose is utilizing this new technology to make visualizing big data at the beginning of the research process more common. But you may be wondering, what even is big data? Unfortunately, it doesn't have a super straightforward answer. You see, the term big data relates to the amount of information available on a topic. Some topics could have millions, billions, or even trillions of pieces of information on them, while other topics, to be considered as having a lot of information on them, may only need a few thousand data points. So when someone says that big data is when you have an incredibly large amount of data, it's all relative. A better way to describe big data would be to say that it's a comprehensive set of information related to the topic. An example of big data is Google's extensive collection of search terms people use, which can be correlated to real-world affairs, such as how the flu is spreading. Another example of big data is the way the website Faircast would compile airplane ticket prices from several different airlines for basically all the flights over a large span of time. You see, big data could refer to a single, large data set that comes from one place like Google, but it can also refer to compiling data from several different places to form one large data set. The main thing when it comes to research using big data is that the study itself needs to use all of the data. Because if you only choose to select a portion of it, it would no longer be comprehensive and thus no longer under the umbrella of big data. So why is it only coming up now that we should be utilizing big data more to improve research? Well, the thing is, it's a fairly recent development. We didn't used to have the technology to store such copious amounts of data, nor the ability to easily access it. Not too long ago, the majority of the world's information was stored on paper, film, vinyl records, and other similar formats. But in the early 2000s, there was a major shift from analog storage to digital storage. In just 7 years, we went from having roughly 3/4 of all of our recorded information existing non-digitally to over 90% of all the stored information being digital. There are a few reasons for this. Improvements in computer-related systems allowed us to store more information easily and cheaply. This led us to converting existing physical information into a digital format. Additionally, we had new electronics, and electronics were being used more in general, which meant that more data was being accumulated. Between digitization and datification, we have more information than ever before readily accessible for use for research. In fact, there's so much data that it led to the creation and use of big data. You may remember that I said big data would help improve research if we were visualizing it. So let's take a quick moment to talk about visuals. We are used to seeing visuals, especially with social media today. It's not even just photographs. Other common types of visuals are graphs, tables, charts, diagrams, and even maps. In fact, visual communication predates written language. Visualizations can help group and simplify data, translating it into a form that is easier for people to make spatial comparisons and inferences. When we look at visuals, we use our spatial thinking skills to interpret the information we see. Our brains naturally like to think spatially, so this makes having visuals incredibly valuable when it comes to trying to understand complex concepts. If you're trying to learn about something that is macroscopic, submicroscopic, or abstract, it can be really hard to translate the words you're reading into a spatial concept. This is why, when being presented with visuals, it is typically easier to understand what is going on because you don't have to create your own mental representation of the spatial properties being described. They're simply shown to you. Another thing that makes visuals an easy way to understand information is the repetitiveness of visual elements. You see, there's certain visual elements that are widely used. Take an arrow, for example. When you see an arrow, you can quickly interpret that it means the object on one end connects or leads to the object on the other end. Or when you see circles around several different objects, you understand that it means these things are grouped together. Because we are used to seeing certain symbols so often, we are able to quickly understand what they mean. It even goes beyond just symbols. Lots of people are used to seeing particular types of graphs or maps, and so as a whole, these are often easier to understand than less used visual formats. I mean, a map of the United States is pretty recognizable. So now you've heard a little bit about what big data is, and know more about why visuals can be so helpful. So let's go back to why we should be visualizing big data to improve the research process. Prior to having copious amounts of existing data or the ability to easily collect it and analyze it, researchers would typically have to rely on sampling. This means instead of taking all the possible data related to the topic they're researching, they would only collect data for a small portion of it and use that to represent the whole. While there are random sampling techniques that are able to give researchers pretty accurate data regarding their topic, random sampling does not work well if you need to break down the data to look at subcategories or if you want to continue to ask additional questions about the data. This is where using big data to take a comprehensive look at a topic comes into play. It can be broken down for researchers to get a detailed look at the subcategories while still maintaining comprehensiveness. The same dataset can also frequently be used for several purposes now. For example, the database of Google search terms doesn't only have one purpose. Today, data itself has economic value and can be considered a raw material of business. Data can be used for its initial purpose and then used again for other projects, be it within the same company or even by a third party. While certain industries are leveraging big data more and more often these days, our current research methods largely focus on still using sampling rather than big data. By using big data more, we will improve our research. But it doesn't simply stop there. If we specifically visualize big data at the beginning of the research process, we gain the potential of discovering new patterns and reducing biases. So let's unpack how we could discover new patterns and what that can mean for research. Well, patterns are essentially correlations at first. Correlations show a relationship between two or more things, and while it doesn't necessarily mean one caused the other, correlations do help reveal what is happening, just not necessarily why. Research is normally aimed at why something is happening, but you can't investigate why something is happening if you don't know what is happening in the first place. So while correlations don't necessarily show the causal relationship, finding these correlations can help steer researchers towards finding out the causal relationship. The great thing is that finding correlations is much easier with big data. The immense amount of information provided with big data can reveal otherwise hidden relationships, because oftentimes to find patterns in data, there needs to be a lot of data. So why visualize the data to find patterns, you might ask? Well, while mathematical and statistical methods can find and analyze correlations, there are times when people still need to look at the data to find a connection between sets of information first. This goes back to how you cannot begin to learn about why two things are connected when you don't know that they are connected in the first place. The enormity of big data can make it hard for people to find patterns by looking at the raw data, so by visualizing the data, our brains are better at comprehending the information. It's important to note that with technology today, visualizing data is not as challenging a task as it once was. We can create advanced digital images and even render 3D models. Now, I mentioned that visualizing big data at the beginning of the research process can help reduce biases. This is because starting with a hypothesis can result in a bias that skews research results. When you start with a hypothesis, you're looking at the data through a lens that anticipates a certain outcome, which could affect your results in at least two ways. The first being the way you choose your data for analysis could be inadvertently tailored to be more likely to produce the expected outcome. The other way is that you could accidentally manipulate and interpret the data in a way that proves your hypothesis to be correct because of the subconscious desire for it to be correct. By visualizing the data at the beginning of the process, before a hypothesis is even created, you can mitigate this bias. If we let the data show us its patterns, the insights we gain from the correlations may help us solve some elusive problems. Now, another important part of research is being able to convey it not only to other researchers, but also often to the general public. We talked about how visuals can help us understand information better, and while visualizing big data at the beginning of the research process is helpful to find new patterns and reduce biases, it's also incredibly helpful to convey information to others. If visuals are routinely produced at the beginning of the research process, then you automatically have the visuals to include in reports at the end. Additionally, by creating them at the beginning of the process, we could establish standards and develop a consistency amongst certain types of visualizations to help prevent the images from misleading our brains and causing incorrect interpretations. This consistency and increased usage of visuals would also make it easier for people to quickly comprehend the graphical information. So let's unpack this a little. When you have two images that appear similar and depict information from the same topic, it's common to want to compare them. However, you need to be careful because if something such as scale, color, or classification is different between the two images, then you risk your brain noticing certain patterns that do not actually exist in the data itself. To prevent confusion, there needs to be a consistency in creating graphics so there is uniformity amongst images that display data on the same topic, and developing a standard practice for the creation of big data visuals would help establish a consistency that would reduce the chances of misinterpretation. Similar to how looking at the data before a hypothesis is created can reduce bias, producing your visuals while you're still trying to analyze the data, rather than simply creating the visuals for the sake of a report, reduces the risk of artistic expression affecting the way the data is interpreted. Another pro to having the images produced at the beginning of the process and included in the reports at the end is that for recurring studies, when new data is added, a new visual can be created that is added to the existing compilation of images. And because there is a consistency amongst all the images, there is no need to recreate all the prior images each time a new image needs to be added, just to avoid the potential misinterpretation. Finally, we've already talked some about how visuals make understanding complex information easier, but I want to point out how if the images are routinely included in reports and have consistent visual elements, then the easier it becomes for people to quickly understand the information being conveyed within the images. So now, let's move on to talk about an example of visualizing big data at the beginning of the research process. I used the CDC's database of death information to get 20 years of data on deaths caused by firearms. I chose this topic because mass shootings seem to appear more and more frequently in the news here in the US, and as these tragedies increase in frequency, the public pays more attention to these devastating events, and conversations seem to turn towards gun control. While the gun control debate frequently looks towards these mass shootings, they rarely take an in-depth look at deaths caused by firearms as a whole. This made me curious about the trends the US is seeing concerning firearm deaths overall, and not just those from mass shootings. I found that there's actually sort of a gap in the information the general public can find related to firearm death statistics. So I sought out to fill this gap and make a compilation of images to show firearm death rates. So let's go ahead and take a look at some of these images now. I chose to display the information on deaths caused by firearms at the state level. This is because if I had chosen the county level, there was a lot of data suppression to protect the identities of the people the information referred to. I also chose choropleth maps because this allows our brains to quickly notice patterns in the color changes. The CDC lets you break down the data into subcategories based on the intent. The categories are suicide, homicide, legal intervention, unintentional, and unknown, in addition to having the overarching category that includes all the subcategories. So I will go ahead and start showing you the maps for the overarching category of all the firearm deaths in the United States for the 20 years of data that is available from the CDC. As these maps transition from year to year, you'll notice some of the states get darker red, and some of the states become lighter. This indicates that their firearm death rates are changing from year to year. I talked about consistency in the creation of images earlier, so I'd like to point out that all of these maps are using the same color key. And they also all use crude rate, which means that for each state, the number of deaths is divided by 100,000 people, so that the results are not skewed based on the fact that certain states simply have a larger population than other states. If you were to look at the full portfolio of maps, you would get a set of maps for each subcategory as well. Within each category, the key remains the same, but between the categories, the key has to change, otherwise some of the categories with very few deaths would end up with the entire map displaying a single shade of red. Now that we have all 20 maps for each category, we are able to look for patterns within the data. The code to produce these maps is shared on GitHub, and as new data becomes available, this code can be used to produce additional maps for the new data. This will let all the maps be created in the same way and will maintain the consistency amongst the images, so this compilation of images can simply be added to, instead of needing to be recreated every year. For the purpose of this thesis, I did not continue on to identify the patterns in the data. The next step would be to identify those patterns and then investigate why those patterns exist. Hopefully, some of the correlations that can be found in this data lead to the discovery of a causal relationship. Once we better understand why firearm death rates are the way they are in various states, we will be more likely to figure out a way to reduce the number of firearm deaths in the United States every year. I hope you see in this example how much we can truly benefit from visualizing big data, especially if it occurs at the beginning of the research process. With the technology we have today, there is no reason we shouldn't adapt our research methods to better take advantage of it. Thank you for listening.